Okay, today we're going to be talking about and working with angle relationships. I'm on page 46 in the book if you want to follow along there, or we're going to start off by defining some terms. All right, so we're going to start off with adjacent angles. All right, adjacent angles, two angles that are next to each other. They share a side and a vertex. All right. How's that? Is that better? Angle relationships. All right, so a picture of some adjacent angles. If we label these angles right here, we got this angle up top. If I put a 1 down here, that could be called angle 1. It's also angle ABC. And then you've got another angle, CBD. Put a 2 in there, call it angle 2. All right, angle 1 and angle 2, they are adjacent. They're next to each other. They both share vertex B, and they both share this side BC. Okay? So another example. All right, angle 1 right here and angle 2. Those two angles are adjacent to each other. Angle 2 and angle 3 are adjacent to each other. And angle 3 and angle 1 are adjacent to each other. They share this vertex right here. All right. And anytime that two angles share a side and a vertex, they are adjacent to each other. A linear pair of angles. They're adjacent. And they form a line. A linear pair of angles are adjacent and they form a line. So anytime you draw a straight line, if you put a point on that line and then draw another line out of it, you just created a linear pair of angles. Angle 1 and angle 2 are a linear pair. All right, they've got they share a vertex and they share a side, but they also, their non-common sides form a line. Let's add to this. A linear pair of angles are adjacent and form a line. They always sum 180 degrees. The measure of angle 1 plus the measure of angle 2 is always going to equal 180. Vertical angles. Those are two non-adjacent angles formed by intersecting lines. They are always congruent. All right, vertical angles. They're non-adjacent, which means they're not next to each other, and they're formed by intersecting, this should be lines, intersecting lines. So if you draw a line on your paper and then intersect it with another line, you just created 4 angles here. You've got angle 1, 2, 3, and angle 4. 1 and 3, angle 1 and angle 3 are vertical. All right, they are across from each other is the easiest way to remember it. They are congruent to each other. The measure of this angle is going to be the same as the measure of this angle. Angle 2 and angle 4 are also vertical. So the measure of angle 2 here would put 2 arc marks, would be the same as the measure of angle 4 right there. All right, a few more terms. Complementary angles. Always sum 90 degrees. Complementary angles always sum 90 degrees. An example of some complementary angles, if you were to draw this 90-degree angle right here and put the symbol in there. So this angle ABC right now is 90 degrees. If you put your pencil on point B and draw another angle or another line coming out of there, a ray coming out of there, put point D on it, Now you've got angle ABD and angle DBC. Okay, those two angles right there, they're complementary angles. All right, because their two angle measures sum 90 degrees. This angle up top, let's say it's 50 degrees, then the angle down here on the bottom would be equal to 40 degrees. Complementary angles don't have to be next to each other. They don't have to be adjacent. If you had an angle over here that measured 30 degrees, and this was angle XYZ, and then another angle right here, angle MNO, and it measured 60 degrees, those two angles are complementary as well. All right, their angles, their sum, the sum of the angles is 90 degrees. Supplementary angles, those always sum 180 degrees. All right, supplementary angles always sum 180 degrees. And again, you can have two different examples of that. You could have a linear pair of angles. Talked about a linear pair a minute ago. If this angle over here on the left is 120 degrees, and these two angles form a line, then they are supplementary, and the angle on the right would measure 60 degrees. Supplementary angles don't have to be adjacent. So we could have this angle here, this angle A, and it could measure 20 degrees. And you could have another angle that's not attached to it, not touching it, angle B, and if it measures 160 degrees, then angles A and B are supplementary. All right, they sum 180. Any questions there? All right, so some example problems related to these definitions would be find the measure. Find the measure of two supplementary angles. If the difference in the measures is 18. All right, so here's how you set up a problem like this. You need to find the measure of two angles if the difference in the measures is 18. So supplementary angles, you got your first angle plus your second angle, and those added together have to equal 180 degrees. Agreed? They're supplementary. But the difference in the two angles is 18. So one of your angles is just called angle X. The other angle would be X minus 18. So here's your first angle. Here is your second angle. And since they have to be supplementary, you set them equal to 180. So now you can solve for X, which is one of the angles. So if you combine your like terms here, you get 2X minus 18 is equal to 180. If you add 18 to each side, then 2x is equal to, yes, 198. Very good, thank you. If you divide both sides by 2, then you get an x equal to 99 degrees. All right. So one of your angles is going to be 99 degrees. This angle right here is 99 degrees. And then your other angle is going to be 99 minus 18. So that's going to be 81 degrees. So there's the measure of your two angles, 99, 81. Any questions there? All right, so here's your practice for today. Your practice is going to be on page 50. Let's do this. We're going to go page 51. Problems 8 through 26. And I want you to do the odds. And I want you to do the odds so that you can check your answers in the back of the book. Page 51, problems 8 through 26. And you can check, please check your answers in the back of your book. All right. Any questions? Yes, ma'am. This is going in the basket when the bell rings.